All right. I think that's.
Let's go ahead and get started. Reversing Web Applications talk with Andrew Wilson. He's a security consultant at TrustWave. He's a member of their Spider Labs, the advanced security team focused on penetration testing, incident response, and application security. He has over 9 years experience building, testing, and securing software in a variety of industries. Andrew specializes in application security assessment, penetration testing, and secure development lifecycle. He's an active speaker in the developer and security communities, and he is recognized as a Microsoft MVP in Windows Azure. And he has one of the shorter bios, so he's like top 2 on my favorite guys so far today.
That's always an improvement. I try to keep it short and simple. So, like you were saying, I work for TrustWave. I work in application security, so predominantly I work with web applications, sometimes mobile, sometimes compiled binaries. We do penetration tests and then source code review for those. That's kind of my day-to-day job. In my free time, I spend time with the Hackers of Charity group, and so after this, if we don't have enough time for Q&A, I'm going to be over at that booth if you want to harass me over there. I also compete and capture the flags with these guys. I train in martial arts with these guys, and it's because of these guys that I get to be here with you guys. That's kind of annoying, huh? What's going on? Can you hear me now? I guess I'll try this. Is this better? Yeah. Okay. So I don't know where everybody is in the overall context on. Hello. Maybe it's that thing. I don't know. I don't know where everybody stands kind of with the overall sense of where you understand reverse engineering, and so I kind of want to make a step back and just make sure we're all on the same page with that. Reverse engineering, traditionally when you hear the term, you think something like this. You have some context of a compiled binary, usually an executable or a DLL. You're going to take the assembly that comes out of that, apply compiler theory, and then usually you can discern fairly accurate context of source code from that, right? It gives you the ability to take from this compiled format and bring it back to source code. That's not particularly useful for us as a definition. It's more of a mechanical understanding of it, because oftentimes with web applications, you don't have like the ability to just apply some theory and pull back out source code from it, right? So if engineering is this art of designing source code, then reverse engineering is the art of deducing that design, right? Taking that design and figuring out how it was built. We're using basically tools to understand these things. We want to know the composition of the application, which is its elements, its components, what it's made of. We want to know the relationships of each component to every component, and then its behaviors, and assert its behaviors out of that. And the reason is because penetration testing is an incomplete information problem, right? It's like a puzzle. We're given pieces and we're trying to figure out how it works, so that way when we go through and we're working with it, we can identify vulnerabilities into it, right? And the greater visibility we have into how that puzzle works, the easier it's going to be for us to achieve that process. If a client ever came to me and said, hey, what would you recommend that we do for our penetration test? I would say, give me your source code repository, give me a live site that's like a UAT instance that I can play around with, and I can find significantly more vulnerabilities than if I have to spend my time trying to reverse and figure out what the application composition is. Does that make sense? But since people don't necessarily want to do that, you have to figure out a way to do that whenever you run into sort of a gray box or a black box type test in order to figure out what that is. That's kind of the ideal state. And so reverse engineering, as far as we're going to define it, is trying to work towards that ideal state. And it's okay if you don't believe me, because every methodology says that I'm right and you're wrong. The Web Application Hacker's Handbook is probably most appropriate within terms of our definitions for this. Most people would refer to what we're going to talk about today as information gathering with analysis. That's why Web Application Hacker's Handbook is probably closer to what we're going to be talking about. And then the PTES is a security standard for penetration testers that just came out. They don't necessarily talk about web stuff, but they talk about information gathering and why it's important. And then obviously the OWASP testing guidelines has a whole section on information gathering and using that from there. Basically the idea is you want to learn everything, right? The first phase of the assessment is to collect everything you could possibly know about the application ever, and they absolutely mean that, right? So you're going to enumerate every part of the application, you're going to get its attack surface, you're going to map out every single area of the application, because the more information that you have, during this phase, the more attack vectors presumably you're going to be able to find as you go through and do it, right? So what that becomes is this laundry list of information gathering tasks. You're going to map visible content, discover hidden content, you're going to test for debug params, identify data entry points, identify tech used, map the surface, analyze exceptions, search engine discovery, test it for application fingerprint. I mean, there's a lot of stuff you do, but nobody actually does that. So the problem with the methodologies that a lot of these guys approach is that they imply this top-down approach, right? Like this process, like you take a checklist and you start here and you work your way through the application, and then like when you get to the bottom, you're done, right? That's kind of the theory that a lot of these methodologies put out. But nobody actually tests that way, because the implication in that is that you do it once and you move on to something else. But information gathering is something you do continually throughout the application. As you're testing it and understanding different components, you're going to get further insight as to how it behaves, what different pieces are and how they relate to each other. And so information gathering kind of happens and continues throughout the life cycle of your test. That's the first reason. The second reason is it's slow. It's an exponential problem. If you took the approach that everybody else does, you figure an application has this visible attack surface, then the discoverable attack surface, and then inside of that, you have to take the metadata and implications and test all of those, and it grows, right? The bigger the app is, the bigger it becomes. And if your job is to do this for a living, and you come to a client and you're like, hey, I spent 3 days information gathering on your application on a 5-day assignment, that's not exactly the best way they want you to spend your money, right? They want you to exploit their system and tell them where they're vulnerable. You get information overload, right? Let's presume that you did go down this approach and you did follow this thing and you're 3 days into information. You have so much information, but if you haven't actually gone through the process of analyzing it and figuring out what it's doing, you're wasting your time. It's too much information inside of how you do it. I saw this quote in a book I was reading called Flawless Consulting. The purpose is not to understand the universe. You don't need to understand the universe. You need to understand enough information to direct your tests so you can continue to do focused action as how you're doing it. Like if you are familiar with formal reverse engineering process, usually they're not trying to reverse engineer the entire application. It's very rare that somebody says, hey, take this thing and then tell me every single component of its source code. Usually it's, I'm really interested in how this one component of this thing works. Can you tell me what are the primary mechanisms in which it's doing it? Can you maybe reverse some algorithms? Sometimes they'll use that for integration, sometimes they'll use that for security testing, sometimes they'll use it for just information and education, but it's really rare that you'll see somebody go ahead and like reverse engineer the junk out of everything, right? Nobody really does that. I think this is how most people actually test, and so that's what we're going to focus on as our methodology within reverse engineering. Is anybody familiar with the OODA loop or OODA loop or Boyd's loop or any of that? Same term for all of those? Nobody. Okay. So John Boyd is a gentleman who you probably should be aware of. He's considered like one of the most recent modern generalist warfare strategy guys in American history. So if you ever study strategy and things like that, he's kind of like our guy. He's responsible for creating the maneuverability doctrines that are used today currently within the Marine Corps as their attack strategy, right? So he has created that doctrines of warfighting. One of the fruits of that process was this thing he calls the OODA loop. It's like his magna opus, or whatever the term is, right? It's like his coup d'etat, right? And what it is it's an observation against how we look at the world and how we understand it, and how we might use that both from an offensive and a defensive perspective to take advantage of stuff. He had a nickname called 42nd Boyd, and when he was a jet pilot in the Korean War, he had a long-standing debate with any single pilot that said, you can start from any position you want, of any position of advantage, you get to choose it, and I'll be in disadvantage, and within 40 seconds I'll beat you. And he always won. He always won. And he attributes a lot of it to this, right, this OODA loop, saying that if I can finish this loop faster than you, if I can go through this process quicker than you, I can make more decisions, better decisions before you're done reacting to it. Basically, I have this initiative and you don't, and because I have initiative, you'll lose, right? So that's how we want to test stuff. I want to test stuff with initiative so I can quickly take over an application and steal all of its awesome secrets. The process for this is observe, orient, decide, and act, right? Observe is that we're going to collect information. Your body is this human information machine, right? You're pulling in, smell, sight, sound, feel the world around you through skin and so forth. But you can't obviously like react to all of that at once. If you tried to pull it in at once, your brain would explode because it can't process that much information. So we apply these filters, right? We apply orientation filters, which are things like our cultural experiences or our backgrounds or our education, in order to determine what of that information we're pulling in is worth paying attention to, right? We decide what that information means, and then we act against it. We just follow this life cycle. And I believe that's more akin to how we test, and that's definitely more akin about how we're going to do reverse engineering. Some caveats. This is definitely not a one-to-one relationship with compiled binary reversing, right? With a compiled binary, you get something and you pretty much extensively have the application, albeit that it's in a compiled format, right? With a web application, you're trying to discover content through a variety of different mechanisms, and what it reveals, it's almost like a poker game, right? It doesn't necessarily show you its cards, and you have to kind of interact with it and figure it out from behavioral analysis. It does more have a parallel to like malware reverse engineering, because sometimes people won't go through the process of reverse engineering it in the compiled binary to source code. They'll put it inside of a VM and they'll let it work its way, figure out what it's doing inside of the application, and that's how you can sort of gestalt behavior and figure out how it might be composed through what it's actually doing, right? That's probably more akin to what we're doing. And the other reason is that web developers, people, we do silly things, right? And so what we might see and think is one thing could very well be another thing. If you checked out, I did a talk at DEF CON this year on this thing called Traps of Gold. My premise is that if you're a developer, I perfectly expect you to lie to me as I'm testing your application. And so if you're running into a guy like me, expect that when you test my application, most of it's going to be made up, contrived, and not accurate. So that kind of throws some dampers into what we're planning on doing. So let's decompose some applications, right? The first premise that we're going to talk about is look at it like a forensics exercise. So the Lockhart's exchange principle is something that you hear about in forensics. One of my coworkers did a talk called like sniper forensics, and I got introduced to it there. Basically, Lockhart's exchange principle is the premise of CSI, which basically says there's nothing in this world that you can do without leaving trace and evidence of how you've done it. Even the process of trying to remove that evidence creates more evidence, and it sort of serves as a silent witness to you. That's how I look at web applications. And granted that when you build an application, generally people aren't trying to like cover up a murder, but I recommend certain developers might want to do that, especially when I've seen their source code. So you probably want to cover up that you did it. It's not something you should brag about, right? So we're going to start with identifying compositions. Web applications don't necessarily have some context of like a PE file format, right? When you get an executable, it doesn't follow this common standard when you're looking at a web application. But we do have some very common abstractions. We start off with a presentation tier, extensively, the thing that you visually interact with and work against. You have a logical tier, which represents the business logic or the rules necessary to perform the actions that the visual tier is interfacing with you. And then you have some data tier, which is the storage and retrieval of that information and modifying it along the process, right? This is the accurate conception model that you'll see. Sometimes it could be distributed across multiple computers. Sometimes the logical tier is meshed with the presentation tier, and so you have kind of very odd boundaries. But by and large, like these are the three primary tasks that you'll see inside of any web application that you're going to be testing, and so this kind of serves as a means to do that. To test it, we're going to focus on techniques that either don't connect to a system, appear as normal use, You're going to test it with two ways. We have passive testing and then we have active testing. Passive testing are techniques which don't connect to the system. They appear as normal traffic use. And examples of that would be things like using Google Dorks or Shodan as a means to like identify additional content or figuring out host headers, looking at versioning, things like that. It's a passive mechanism in the sense that you're looking somewhere else for it. Active testing is the opposite of that. That means you're going to go in there and you're going to play around with it and you're going to, touch it and fondle it and find out what it's actually doing. Passive testing reveals what I call a happy path, right? What the developer expected me to do inside of it. And then active testing is more of an optimism test, trying to see how optimistic they were and how much they enforce you actually following that happy path, because oftentimes that's not necessary. These terms, I've been thinking about this a lot. I don't like the concept of active and passive testing. I think that we should probably take terms out of social engineering because I think it's more into what you're doing. And I would say the difference is you have one which is an elicitation. Elicitation is discerning information that's really valuable through the course of a normal conversation or within sort of the guidelines of a normal conversation. And then you would contrast that to a concept of interrogation, right? Like beating the application into submission and telling you what's going on inside of it. Mostly because really you can't tell me that you're not actively testing it if you're using the application in order to information, but elicitation is kind of more in line with what we would be looking at for our test. This thing's driving me nuts. So when we said that people don't actually have a common file format, that's true, but people do follow either formally or informally common design patterns that you would see within our industry as a developer. The first one that you're going to run into is a page controller, which works something like this. You have a view, you have a controller, which usually is the page itself, right? So if you go to a page like, do action.aspx, you'll see that. And it usually is responsible for merging the view and the presentation together, like the business logic. And it might be kind of like this all-encompassed spaghetti code is kind of another way people often refer to it, but the page controller approach, right? You can identify this pretty easily by having a lot of single action pages, right? So you might have a page that says like save model or update model or review model. That would be an example of most likely than not a page controller. These have usually a lot of different client-controlled variables because each page actually works as an independent silo, which is why it becomes spaghetti code really quick, is in order to get one page to talk to another page, they have basically their own little interfaces that you have to talk to, and so client has to send data along the road to it. Usually it's in query strings, it's sometimes in post data, but most of it's client controllable when you run into something like this. Or it has a PHP file extension, like that would be another way to identify it. It's not exactly true, and it's kind of more of a joke, but what we'll talk about a little bit is that when you run into certain types of file extensions, they oftentimes imply how they might have been developed. Since PHP, it's really popular over a certain time period to have done page controller type approaches. That's like anytime you run a classical ASP site or a classical PHP site, I can pretty much guarantee you that it's going to be a page controller because at the time that model was very, very popular among developers. Anybody know, just maybe off chance, what sort of a most recent developer pattern that people are using? Okay, we'll get to that one in a little bit. In fact, we'll get to that one right now. It's right behind me. How about that? So model view controller is probably the most popular design pattern that you'll see right now inside of application development. And what happens with that is that you interface with the view. It has a controller behind the scenes which defines a whole bunch of actions, and then it binds a model to that, and it shares that model back up. As an example, it looks something like this, right? You go to a URL structure, you'll see it has a controller name, it has an action, and then usually an ID in which it's acting against. It's kind of like a sentence proposition, right? How it's going to interface. Sometimes you'll just see the controller, which implies a default action. Usually it's like a list where it creates a set of values. And then finally, you might see just an ID, which implies a default controller and a default action. A controller might have things like update, retrieve, delete, modify, whatever. And so usually, let's say you had like a product, it would be like products, save, and then the ID would be the ID of the product. Does that make sense? Pretty straightforward. You generally don't see very many parameters in the query string when you're working with something like this because the parameters get sent through the actual URL substructure. That's how it communicates with itself. Or you see post data where it comes down and then it routes it inside of the controller, and it's kind of a little bit more fancy. The worst microphone ever. And it's very popular in certain languages. So if you run into like Ruby or you're working inside of certain frameworks, it's very straightforward that they work in this way. It's really easy to identify that somebody's done it this way because the language itself kind of has an implication on what people are using from a modern perspective. Like anything in Ruby is pretty much an MVC model, pretty much across the board. And then finally, we have a front controller. So a front controller is something where you have an index page or a default page which handles a variety of actions, but the actions are passed as query string parameters. So if you ever see something where it says like command or action, and then the name of the command in which it works with, that's kind of how it does its navigation. So it acts as a router to maybe something underneath it, and then the command is how it's probably implemented behind the scenes. So when it sees something like history, it's probably a case statement that says if you see command history, route to this, or it instantiates the handler for it and it modifies the request through the two of them. If none of that makes any sense whatsoever, kind of a compare and contrast I put together for you guys is if you have like a page controller, it would be like do query, and then in the query string you'll see the parameters that it's trying to operate against. If you see a front controller, it's going to say, here's my index, my action is do query, as opposed to being the page itself, and then it has parameters. And then finally, an MVC would be like query my param and then maybe a subparam, and then it goes ahead and queries the database for you that way. Does that kind of make sense as a common pattern? Okay. Something else you should be familiar with, especially if you're doing penetration testing, is there's about 3 different ways people interact with data pairs. I originally had like a slide on like data access patterns, but the reality is two things. One, you're probably not going to be able to discern that unless there's an exception that tells you how it's built, which sometimes there is in the stack trace. But also it's somewhat irrelevant to your testing process. It doesn't really matter what access pattern they've done. What matters is how they've actually created the connection strings to talk to the database, which is not a data access pattern problem. It's a connection to the database problem, right? So there's three main ways for that. The first is the horrible concatenation of strings. If you do this, I'm sorry for you. Please don't. Everybody knows why this is bad. Anybody not know why this is bad? Okay, cool. Second way is a prepared statement. A prepared statement looks something like this. You'll see select star from the table. It has like a replacement parameter, and then it does binding and it automatically will handle the encoding for you kind of on the fly. And then finally you'll have stored procedures, which are very unlikely to be something that you can do SQL injection against. But occasionally, if they write really, really bad stored procedures, you might be able to take advantage of that. Oftentimes it would be like a search query that somebody creates, because when you do that, usually they want it to be dynamic to handle a lot of different searching scenarios. So even then, sometimes on stored procedures, you can get an attack vector. Some inconsistencies. Sometimes when you're looking at a URL, it could be a URL rewriter through Apache. It could be like an IIS URL rewriter, so whenever it hits a URL structure, it could be that the underlying framework is like a command pattern. So if you've ever used WordPress, WordPress has the same deal by default. It's a front controller, so it has all the actions off the index page that it's going to call, and then it uses those recursive calls to create the app. But you can have it rewrite inside of its configuration to look like an MVC pattern, even though it's not. What's cool about that is it supports both methods, so both methods can be tested for inconsistencies in access, so you can look at something like that in that way. That's kind of how that works, because it does that. Some basic rules, right? If you can cheat, you should absolutely do that. So if you ever see something like this, where it has an exception message saying upload failed, and in the corner it says Discus is how I built this, then the very next thing you should be doing is download Discus, right? If they're going to be so willing as a developer to tell you how you've written it, like if I'm going to brag like, hey, I wrote this in Drupal, or hey, I wrote this in Ruby, or hey, I wrote this with Discus, it's absolutely to your benefit to download that framework and use it, because again, this is a visibility concern problem, right? So the more visible I can be into your application, the easier that I can test it, right? Like, how would I test ever for misconfiguration of your application if I don't know how it's supposed to be configured in the first place? So oftentimes what happens with this is you can see things like WordPress will put in metadata, Drupal will put in metadata, there'll be default content, default files, things of that sort. You search for those whenever you're in a test in order to start fingerprinting this application, because if I can figure out the version, I can download it, I can play with it, and I can see either A, if there's known exports for it, B, if you've configured it right, or if I'm really, persnickety, I might look at that application and see if there's any additional vulnerabilities that people haven't found before. So cheat, right? If you have that opportunity, you should absolutely do that. You also want to pay attention to where technologies intersect. Oftentimes when you work at a very complex application, it's usually some subset of HTML. Sometimes they have like a Silverlight or a Flash or some sort of component in that sense. And then oftentimes they might have like an AJAX handler. It's kind of a big one that you want to look for. Whenever technology intersects between that, it usually means you're going to have two different subsets of developers, and they may not necessarily know all the communication patterns. And so identifying this early on in your application as you're trying to reverse engineer where these just separate is really useful, because later when you come back and test it, you might find authorization bypass, you might find privilege escalation, things of that sort. For instance, like sometimes you'll find a front controller that supports different types of actions, even though the action isn't necessarily supported. So your auth might be, hey, you can't call this page, but I could call from one front controller into another front controller with the same actions and then edit it, just because it's supported across the board. Or where AJAX might handle something like that. That also brings up that these are oftentimes hybrid, so it's not like you're going to find one design pattern and that's how the whole application is going to be built, for two reasons. One, developers aren't necessarily always aware of how they've built the application. Like they don't necessarily say, hey, this is the standard formal model that I'm going to use. And then also is when they create applications that are composed of different types of things, they have different types of interactions inside of it. The question maybe that you have is, why does any of this matter? And I would say that anything that a developer says against, you should use it against them, right? So the access patterns, how it works, the name of the parameters, all of that's super valuable, especially if you're trying to build out a type map for testing later, which we'll talk about. If a developer is so very willing in order to find particular things, it's pretty great. You can use that as a means to identify and pull out later parts of the application for better testing. Second is that every pattern has a strength. Right? MVC is suspect to this concept of model binding, which is sort of like a complex insecure direct object reference. But you're not going to find that in any other framework. If you don't know that it's an MVC application, you can't test it for that, nor should you test it for that if it's some other application, because it's not going to bind that way. Does that make sense? And then same like I was saying before is that if it's a command pattern, sometimes you can access different parts of the application by injecting commands that you learned about in other parts of the application. So if you're given a task with maybe with 2 different levels of credentials and I go through and I'm an admin and I see that there's all these admin commands, usually what you want to do is collect those, create a type map, come back to the site as an unauthenticated user, and then replay all the different commands that you used to play as an admin and see, hey, are they actually supporting authentication, right? That's why you want to know what this pattern is, because you will never have the ability to inject against it if you're not familiar with what that pattern looks like. Does that make sense? To be savvy? Sweet. And then finally, the pattern themselves can kind of imply how the data access is working, kind of like we talked about before. With MVC, it's almost always traditionally that you'll see they're using an ORM. Because it's an ORM, it's pretty rare that you're going to find SQL injection under certain types of systems that they've built. Like active records, not necessarily something you're going to find a SQL injection with. And even if you did, you should probably just download active record and test active record, because that would be the only place in which the SQL injection would exist. It would be a bypass against the framework, not against their site. And so those are reasons that you want to do this and understand it. Is there any questions on this? Everybody make sense? Cool. So then the next part is trying to understand behavior. Once we understand how it's composed, we want to look at what does it do, right? So we're going to go through this kind of psychoanalysis process of how the application is composed. We want to know what an application does, kind of the happy path, what it supports, and then we want to know what it doesn't support, right? And to do that, we usually will take and go through, when you hit an application, I would say that 9 times out of 10, the process of testing is going to look something like, get your credentials, log in, play around with the application, figure out what it does. Something is going to trigger in your head, hey, this doesn't look right, this does look right, and you're going to play with it to get more information. And this process is kind of the play with it to figure out what it does. What it does, you should pay attention to a few things. First off is, where did your data go? So if you create a user record, you want to know all the different places that user record is going to be redisplayed, because then if you find things like cross-site scripting attacks or CSRF type attacks, and you want to put those together, understanding how those applications works and where the data goes, that's going to be pretty important, right? You also want to pay attention to things like, how did it get there? If it moves from a post, did it move from a query string? Did it move from a cookie? Did it make 2 steps when it could have made 1? So is it a post back to itself, which gives you to a redirection, which then brings you to another page? Or is it a post to another page, which then takes you to another page? Those are actually really important behaviors, because they have a couple of things. First off, they imply a relationship between those pages. So if you want to test them, maybe you can bypass an entire subset of that and call the individual page between it. So those are going to be things you want to pay attention to as it works, so that way you can kind of further get visibility into the application and what its relationships are. You also want to know if your data was encoded or modified and how it went from one place to the other. So usually, some people will create like the XSS fuzzer and they put in all this stuff. That would be an interrogation method where you're like trying every single encoding for different parameters. You could also just create a username that has a bunch of different types of those parameters and then just save that username. And that's kind of in par with how somebody might create something or an accident they might put. And you can usually figure out how they're doing encoding, maybe what they're missing. So later on in the testing, you might be able to do bypasses with that. For instance, in like ASP.NET applications and web forms, the default encoder doesn't support single ticks, right? It doesn't do any encoding against a single tick. So if you see that the data is brought from one place to another, but it's injected inside of a JavaScript, you pretty much can have JavaScript injection. It's not going to be very difficult to find that, because you can do breakouts that way. And then obviously the redirection that we talked about before. As you're going through the application, you want to identify what types are in the application. So usually type system is composed of basic and complex types, which means something simplistic, something complex like an object versus a single type. In both cases, you're really concerned with, do you require this information? Is it required? and then what does it do, right? Those are the two questions you're going to be asking the application as you interface with it. For basic types, they usually exist inside of query strings, forms, URL composition. Anytime you see a URL position, for instance, like with MVC, that's kind of a type, right? It's going to be recognized as a string, gets passed into the URL router. The URL router matches it with regular expressions and figures out where you're going to go. Understanding how that data is going to be leveraged will be really important if you want to do things like directory traversal against URL structures. Sometimes you'll find that. So you want to pay attention to that and where it exists. And then you want to identify whether or not it's a string, whether it's treated as a string, whether it's treated as a numeric item, or whether it's a GUID. Those are kind of important things. All the other types are possible, like numeric, you could tell whether it's a long, or you could tell whether it's a decimal or an integer, like whatever. It's one of those categories. Sometimes with a complex type, it's pretty obvious, right? So this is from a fairly popular system called Nerd Dinner, and you can see that it's got a dinner ID, a title, event, and you can pretty much assert that that's probably the complex type on the page necessary for your interactions with it. And if you look at the actual source code, it's pretty confident that's it, right? That's your source there. Exceptions. This is kind of the non-happy path of testing. I love exceptions. Exceptions are great. Exceptions are a developer's bane of existence, but it's like my favorite thing in the world. For exception testing, I really only do one tool, because we talked about, I think I said I was going to talk about tools. I use Skipfish. Skipfish is this really amazing scanner that does not find anything I would never find by myself. Like I've never found something with Skipfish that I couldn't have identified easily. But what Skipfish really excels at is breaking applications on purpose. And when you go back through its log history and you see what it's doing to break those applications, oftentimes those reveal a lot of other parts of the application through doing it. Like you might get a stack exception, you might get a server error, you might get some sort of application engine handling error, and so that's pretty awesome. These are really valuable tools to learn from it, right? So you can use them as a means to determine the type of number. You can put in negative integers, you can put in large numbers, and you can use it as a means to identify what the underlying type system might be. So if you put in like this is the amount, you put in the letter A, obviously you're going to get an exception. This is A isn't supported. If you put in 10.0, then you're going to see that it's not a valid amount. If you put in a very large amount, you can pretty much assert that this is most likely an integer, right? And that's how it's going to be parsed. Does that make sense? It's a pretty easy way to figure that out. Even if it doesn't tell you it's wrong, right? If it just puts a little asterisk and says, please correct your data, like that's just as information telling, right? It's just as behavioral, easy to understand, because whether or not they've said this, the fact that they're rejecting it, the sheer fact that it's not valid gives you the ability to understand how it does it, right? Where this really stinks is if this is being treated as a string, right? Because then it's just going to get swallowed and you'll never be able to figure out what the underlying type is until later when it actually needs to be that type. Does that make sense? A lot of developers create like varchars and they save them as varchars. If it's treated as a string, it's most likely that the underlying type system is a varchar, or they've done integer conversions where they take the string and they cast it as an integer later. So you'll see breaking either now or you'll see it later based on whether or not that string is valid. Does that make sense? Okay. You're going to learn a lot of things from exceptions. You can also learn whether or not a field is dynamic or static. In that sense, you can put in a value like 1 plus 1 and see if you get the numeric equivalent of 2. You can do 1 minus 1 and see if it's the equivalent of 0. So whenever you run into like an MVC pattern or something where you see like a product ID equals, if you do 1 plus 1 and you get 2, then there's a fairly decent chance that that field is being injected into a SQL statement that you can then modify for SQL injection. Right? This is how you're going to find things that are blind inside of the system, just based on whether or not it's passed dynamically or handled that way. More often than not, you'll get a failure saying that 1 plus 1 is not an integer. That's fine. But that's going to tell you a little bit more about the application side of it. You can also use this as an approach for testing whether or not a string is dynamic by doing things like string concatenation inside of your variable name. So if I have like, XYZ quote plus, another thing XYZ, if it concatenates that and it puts it into your data structure when you retrieve it, you have potentially a SQL injection field, because what it's doing is it's taking that, passing it into the database unchecked, and then it's being condensed as the SQL injection, or the SQL is being processed. So you can use it as a means to test whether or not the field is dynamic, and then use that as a different way to attack the application from there. So, cool. just like debugging, new errors are better than old errors. New errors mean that you're getting a lot further in the application. So as you're testing something, if you get an application that says, hey, this is failing, sometimes you might actually have to fix that failing code in order to test one level deeper, one level deeper, one level deeper. I just did a blog post, if anyone follows me, on an exception where I went to a page didn't even have the JavaScript on it that it was trying to load, but it was an injection point. So anytime you get to the JavaScript, it fails because that's the exception. And so what I ended up doing was fixing their JavaScript for them in order to create the cross-site scripting attack that I could then show them reflected, right? So sometimes that's a necessity when you're doing a test. Usually what it means is that you're missing required data. And that's going to be something that you'll evaluate as you go back through and you look at how things interact with each other, like, is this data needed in this place? If so, how can you modify and add it back to your request in order to determine whether or not it happens, right? Usually when you're testing an application for behaviors, it's not in your best interest to try to modify every single value at once. Or it's not even in your best interest to take automated tools which do that, because again, it's going to create so much information that you're going to then have to figure out how it works. You might as well have done it manually in the first place, right? So take an application that's got form fields, play around with each one and see, does the application throw an exception? What are the limits of each variable type? And that's going to help you determine whether I'm still stuck in the view model creation, whether I'm stuck in the data tier, whether I'm stuck in the business logic tier. This is going to be your kind of primary tool for doing exactly that. Applications will fail in different places, and it's kind of exactly what we were just talking about. Another way that you can discern how an application is behaving is looking at the timing based of the attack. So pretty common inside of blind SQL injection attacks is you're going to create something that makes the system wait longer. So SQL as a language supports a variety of different commands, just like any other programming language. Some of the ones that it supports are either time wait type stuff, where it says, hey, wait for 30 seconds. Or you create a mathematical problem for it that takes a long time for it to solve if something like a WAF is looking for how that thing actually interacts and then goes from there. And so whether or not it's taking its time is going to tell you whether or not your ability to affect the application, where you're able to affect the application, or even if it's broken, right? So if I'm looking at a report page and I'm testing something for how it works, right? Let's say I'm going to get an exception back. If I modify one field and I'm getting it back super quick, then it's pretty confident that there's something inside of the controller that's checking that variable and it's failing before it ever hits data access. Let's say I change that field to get it to work, but it's still failing. I'm still getting maybe even the same exception, but it's taking twice as long or 3 times as long. It's a fairly good chance you've moved down inside of how the application works for testing different routes inside of it. Does that kind of make sense? A similar pattern that you'd see inside of static analysis, has anybody used PEX before? No. PEX is a .NET framework tool that'll work in like C++ or C# or VB.NET, whatever you're using in .NET, that creates fuzz testing for you that run failure patterns. And what it does is it basically walks through every single use case possible of your application by saying, hey, if I've got a switch statement and I have to value match these things, it'll create tests for you dynamically, which makes sure that every branch of the conditional statement is executed, if that makes sense. That's effectively how you want to test it to understand what it's doing, because then you can use that as a means to get further reach deeper into the application for different types of testing. Some tips. Anything it says or doesn't say is very revealing. It doesn't matter, right? So whether or not it throws an exception is very verbose, no worries, right? If it still throws an exception, that very statement itself is very telling on how the application behaves. If it gives you the stack trace and it tells you how it was written, even better, right? That's great, that's awesome, congratulations. But you don't necessarily need it. It just makes your life a little bit easier. And you shouldn't trust tools too much. Sometimes tools create their own problems for you, like Skipfish, albeit that it's awesome, sometimes can create a lot of false positives in the sense that you're overwhelming the server and it has nothing to do with the application. So you run into scenarios where you're breaking the server but not the application's behaving fine, or you've overwhelmed the application so much that you can't discern viable results out of it. So that's kind of the finesse that you'll have to get into as you work on, basically it's a type of fuzz testing to see where it fails, right? Any questions on that? Okay. So just kind of sort of some final components to that, right? OODA testing is pretty awesome, right? This is how you should be looking at your application, very iterative. When we were just talking about our process of reverse engineering and testing the application, you learn a lot through actual exploits as well. For instance, some exploits will give you greater visibility in how the application is working in its first place. I don't need this fancy pants, information gathering, spend 2 days trying to understand how it works. If I can get into it, do one test to see if they've accidentally published their Git repository, download the entire source code for it, what other information gathering do I want? I have the whole application from there. Is anybody familiar with the DCBS attacks? Anybody seen that? My friend Adam just put together a talk at DEF CON. He did it at ShmooCon, I think, as well, with this attack that actually goes back, tests the application to see if they've accidentally published their source code repository, which happens sometimes depending on how you release. If you release with that publishing up on the web, I can pull it down, every single revision of it, and I can look at your source code history, and then I know your application, right? Another one is focus on directory traversal if that doesn't work. Is if I have directory traversal, then I can download the source code, and then I can figure out how it's working. If I look at SQL injection next, I can maybe take over the database. If I take over the database, I can take over the server. If I take over the server, then I can download your code, right? I'm working on tasks that are going to constantly be going through this iterative loop in order to increase my visibility of the test as I'm testing it in order to gather information about what it's composed of. Because I don't like guessing, and you probably don't want to pay me to guess on how your application works. It's not tremendously useful for your funds. Your application is your guide, right? You should be asking it tons and tons of questions as you go through. And how you ask it a question is really, really, really important. It's a finesse. Like I kind of said, I think elicitation and interrogation is kind of the best way to understand how you're going to be doing this, because it's like good cop, bad cop. Sometimes I'm a bad cop, right? If I'm on an app and it's just going to continue to tell me the truth and it's super stable, then I'm just going to spam it with a lot of stuff. And if I get deviations in the results from it, great, that's awesome. But sometimes the application can't support a type of test like that. It's not as truthful, or it's more finicky, right? So you have to learn how to ask very specific questions as you come through and use the application, or it's basically not going to give you the answer you want, or it's going to lie to you with the results. Does that make sense? Listen to the application. It's going to tell you a lot of different things about it. That's how you make informed decisions. If you come through and you find information relative to a stack trace, you can use that against it in different places. One of the attacks that I did a little while ago is I found directory traversal. Directory traversal is great because you could download system files, you could download a bunch of known things. But in this case, the developers were even so nice to me, they actually left paths to the source code inside of their developer comments. So once I had that, I just downloaded all their source code because it was in the comments of the application, right? And you use that against them. I had another test just very recently on the same blog post on the JavaScript thing I was telling you about, where I figured out that if I just took something that looked fairly unique to the application, you don't know what the CMS is, maybe the CMS does a really good job of hiding itself. Basically, you take the names of the application components and you create enough Google searching for it. You can use that as a means to fingerprint the application and then download it based off of that. So you download something, you look at the version history. From the version history, you can test the application to determine how it works. Another thing for testing, although we didn't have it in here, is that as I look at the application, if I find myself in a scenario where I have two files that come back, or I have a file that comes back, and it could be any one number of version, how might you be able to determine that version of the file? Does that make sense? So let's say I find a default file for WordPress or something. How do you fingerprint whether or not it's WordPress version 2.2, 2.3, 2.4, 2.5? Does anybody know? Okay, that's a way you can look for differences in the file. What else might there be? Modified date? Yeah. There's a couple of tools that I might use if I identify that it's a CMS. One of the tools that I prefer is CMS Explorer. CMS Explorer will do a couple of things for me. First is it'll help me fingerprint the application if it knows by looking at default directories. Then if it finds these files, what it's done is it's created a hash sum of every one of the files based on modification, and then it compares the hash of the file it downloads to the hash of what it has in its database, and it says if this hash matches this hash, it's a fairly good chance that it's this version of this framework. That's the first thing it does. The second thing it does is intelligent browsing. If I identify that it's WordPress or Drupal, the next thing I'm going to do is download all the different plugins to see how the plugins are created, and then I can create a very intelligent word list based on what might be there, and then scan for it, and then figure out what that content is that might be there. And then in some cases, I've actually found SQL injection that way off of plugins that they were using to their database off of the CMS that they've pulled into. Again, our strategy is to increase our visibility as we iterate through this application and continue to ask questions. As it retrieves results from these questions, we're using that as a means to drive ourselves forward continually. Bad news is you really can't do a lot to stop that because this is always going to be true. But you probably shouldn't be so stinking obvious about what you're doing inside of it. There's no law that says you can't remove metadata, you can't remove fingerprints from the application if you're using Drupal, for instance. Your EULA says you have to have a license included on the server somewhere if somebody asks. That's all it says. So maybe it might take you a little bit of time to go back and remove some of the default content that you're not using, remove some of the sample files, because it's benefit, right? If knowing's half the battle, you should probably shut up about telling everybody how you developed everything. That's kind of how that works. I think we have 5 minutes. Does anybody have questions for me while we're going through that? I only use a few tools. The first tool I use is Burp Suite. Burp Suite is probably the de facto web application pen tester tool. It's still the best on the market for a variety of reasons, and so that's kind of like the primary tool. Beyond that, from a scanner perspective, like I said, I only use Skipfish because it breaks stuff and it's pretty awesome. Beyond that, it's independent to the process that I'm working on. So if I identify that it's a Drupal type app, I pretty much spend the rest of my tools on focus tools or focus scanners that automate the same sort of testing I would have done anyways, and that's it. That's pretty much all I use. I don't use like commercial scanners. I don't use very popular frameworks like that. They're too noisy, and kind of like I was telling my coworker yesterday, you can't really feel what's going on because it's throwing exceptions all the time. You don't know what that actually means. Like Nick2 is a great tool. I'm not going to knock it, but when you run into a result that says, "Hey, I found this thing," but it doesn't tell you how it found that thing, you're not really in a solution where you can then better go back and figure out what it is, unless you then go back and reverse engineer Nick2, look at how it was doing the test. It's like, why would I do that? Why don't I just test for it? So I don't use a lot of tools. This is my tool between my ears, and I use it fairly often. I think you had a question.
What about during the beginning of the test? Is there enough time to put your entire result to view? So, this is a pretty common problem. Where do you recommend focusing your time to do that?
Sure. Kind of like what I was saying before, is every test that I do is always driven towards the task of giving me more information quicker, right? I'm trying to remove the veil of visibility. If I have access to the source code and the test, then I don't need to do a lot of this testing. I'm just going to look at the source code because like SQL injection is an easy thing to find inside of source code. It's very difficult to find on the web remotely because it involves a lot of parameter testing. It's kind of annoying. It takes time. But if I have access to the source code, I could just grep for data access, look at the data access patterns. I could tell you definitively one way or the other fairly quickly how to do it, right? So a visibility concern. So all of my testing is geared iteratively towards creating greater visibility in the application. Like I said, if I could download the source code, I'm going to do that. If I could steal the source code, I'm going to do that. If I could take over the server, then I'm going to do that because then I could steal source code. If I could take over the database, then to take over the server, then steal your source code, I'm going to do that. That's my process of priority with testing because that gives me the greatest amount of visibility faster, and then I can have my ideal. That's what I want, not your ideal. Does that make sense? And so iteratively, that's how I work down my tests. It saves me a lot of time. I've been in apps before where in less than a few hours I've taken over the whole thing, downloaded the source code, found several critical vulnerabilities, and I'm done. I've had other tests where I've done things exactly like this. I found evidence that somebody else might have been there before I did, right? So this approach is fairly successful. It's very easy because it doesn't separate out tasks like information gathering and then testing and then review and then analysis, right? Like I do those together as I'm working with the application, but in smaller pieces, kind of each one driving the next. Any other questions? This makes sense? Is this easy to follow? Cool. So I guess that's it. I'm going to be hanging out over at the Hacker for Charities booth probably the rest of the time. So if you have any other questions for me, I'll be hanging out over there chilling. So